Hi class, this video is going to help with histograms, and you should have seen these before in Math 1000 or in any of your other math classes. But what is a histogram? It shows distribution and frequency. The bars touch unless there's a gap in your data, and the vertical scale shows frequency, so up and down shows your frequency, and the horizontal is the classes. So just like we've been setting those classes for our frequency table, it's really the same kind of idea. Basically, if you took your frequency table and you flipped it around and drew bars, it would look like a histogram. Okay, so why do we use a histogram? This is important. The visual display shows us the shape of the distribution, and we need it to be bell-shaped to be normal. So we're looking for that visual display for a bell. Okay. Another use is we can easily see the location of the center of our data, and it shows how spread out your data is, and it can help you identify outliers. Okay, if I said those too quick, you can pause and write those down. Okay, so what does it look like? Let me show you one down here. Ignore this one right here for just a sec, so I'll cover that one up. Here is a traditional histogram, and it's of that same data we've kind of been looking at, is McDonald's and how long it takes us to get our food. So from 74 seconds to 124 seconds, 0.5 on both. We have 11 people in that category, 20 something and so forth. So we can easily see the center of the data is about between 124 and 174. So we could estimate it, halfway between those numbers or something like that. So we can also see that it kind of goes up, down, and then it straggles down this way. And we're going to learn that that is the tail goes to the right. So we could say that's skewed to the right. Now these ones are so low that I would say this is just bell-shaped, but it could be skewed, which we'll look at in a sec. What is this one here? Sorry, I shouldn't have moved that so far down. What is this one here? This is a relative frequency histogram. So a relative frequency histogram has the same shape and horizontal scale. So it looks the same and it has the same horizontal scale as a histogram, but the vertical axis is now percents or proportions instead of our actual frequency. So what we do is we add up all of these numbers here to see how many data we had, and we take that 11 and we divide by how many total, and that would give us our percent that we are for that first bar. So we're getting the percent of the frequency instead of just the frequency. And that's a relative frequency. So we've seen a relative frequency table, so now we see the histogram. Very, very similar. All right, so let's look at these four, and you might just want to sketch these. I wouldn't just sketch the shape maybe, but like with the little bars, well, it doesn't matter. So this shape right here is a normally distributed set of data. This is our histogram, and it is bell-shaped. Okay, so we're looking for bell-shaped histogram for normal. This one I would call uniform. I think that's pretty self-explanatory. They're all pretty close to the same. So it's a uniform histogram or distribution. Okay, so this one is skewed to the right. That means the tail goes to the right. Okay, and they sometimes call that a positively skewed. So if my tail goes to the left, it's a negatively skewed, and so remember, we talk about skewed probably throughout the whole class. So if you see data and the tail is to the right, then it's skewed to the right. Oh goodness. Okay. So let's take a second. One other thing, we're going to show this on StatCrunch, is we have something called a normal quantile plot. We aren't going to study this in super detail. This sometimes called QQ plot, I think is where one thing said it was called, but it's a normal quantile plot, actually takes our data for us, and it sees where it is on the normal distribution from -3 to 3, which we haven't really talked about, and it then plots a line based on that, or not a line, like a scatter plot, like a dots, right? So what we need to know for this class is if I have a really small set of data, I'm not going to be able to look at a histogram. So I look at what we call a normal quantile plot. And if it forms a line, then it is normally distributed. So what do you need for your notes? If I see a normal quantile plot for my data and it forms a line, then it will be normally distributed. And I don't see that I put the one I didn't put to be normally distributed. You need to add that. I'm like, I just put form a line. I was just like, form a line, form a line. I forgot normal. That's super important. All right, you have one question on that last one, and you just look at the data. Does it form a line, or the graphic gave you? So you do need larger data sets for these histograms, and smaller data sets, you have to use that normal quantile plot. Okay, so I'm going to go to StatCrunch, and you can go straight to StatCrunch. You don't have to go through MyMathLab. You have a subscription to it now, and the password and username are the same as your MyMathLab. It's already logged in today, so mine just went right in. So I was going to do that McDonald's data, but we have to have data for that. So let's make some up. Let's say it takes 20 seconds, 30 seconds, 50 seconds, 60 seconds, 65 seconds, 85, 87, 89, 90, 100, 120, 120. I'm going to do a bunch of 120s, 130-ish, 125, and then 200, 240, 250. Good, I'm good enough. So to make a histogram in StatCrunch, you have to have your raw data. And then I'm going to go to Graph and go down to Histogram. And then from here, you probably need to play around just to make it work. But one variable. So I'm going to click that to make it show up over here because I'm selecting that data. Because you could have a ton of data in your StatCrunch and you want to make a histogram of a specific column. And group by, that's optional. We want frequency. They also have relative frequency. And let's start with 0 and let's count by 20s and just see what that looks like first, and we'll change it up. And then there is our histogram. So we're counting by 20, starting with 0, and there we go. What else could we do? We could see the frequency on the one side. We could count by 50s and compute. What's this going to do? It's going to make less bars. Okay, so it kind of depends on, can you hear that? Maybe because I have a headset. There's a woodpecker pecking my wall right by where I'm at. Anyway, kind of cool. And they're really small. I thought after Woody Woodpecker, they'd be a lot bigger. All right, that's how you make a histogram on StatCrunch. Make sure it's got the frequency right up the side and your classes down here, and you start with your raw data.